41, 42, and 43 is it's a little bit weird. It's no too important. It's I want to explain, no, but it's I never put this in the test. But I want to explain because it's important. It's the some mathematical book define one indicator or estimator in which bounded the zero of the polynomial. No? So now, what is the formula? The formula for this estimator, capital M, is a famous estimator, but it's roughly, it's no accuracy 100%. And this is the maximum of the coefficients of the polynomial divided by a sub n. Let's practice in this first example, the 41. 41 is a polynomial x to the 4th power plus 2 x to the 2nd power minus 3. No? And let's do in the top part. The top part is maximum coefficient. So I need to find the maximum between 1, 2, and 3. And actual value 3. No negative 3. 1 here, 2 here, and 3 here. It's over the 3. And you take the bigger number, right? Divided by a sub n is always this guy. Because the notation is A0, A1, A2. Because A2 no. A2 no, sorry, this is A2 because it's the same exponent of this. This is A4. Then our example is A4. The A4 is 1. And 3 over 1 is 3. Okay, and this is the answer. So it's the zeros of this polynomial is bounded between minus m and positive m. So the zero is bounded between minus 3 and positive 3. Guess this option. But this not always work 100%. You see in 42 doesn't work. In 43, yeah, I suppose yes. Well, let me try. Do you understand the idea? It's weird, eh? It's estimator. Okay, the mathematician create this estimator because before computer and internet, we have no Desmos, we have no software online. Therefore, mathematicians are doing everything using pencil and paper. Now, using technology, this estimator have no sense. This is to have some idea in what interval lie or bounded this zero. Okay. So this we are doing too fast and accuracy and Desmos. Any question? You understand the idea or no?
Yes.
42 is a typical example in which doesn't work that formula. Okay? Because it's 4 x to the 4th power plus 3 x to the cubed power. So this formula maybe work and maybe doesn't work. The majority of the scenario work, but not always. 3x plus 4. Es obvio que the maximum coefficient, maximum, and between 4, 3, 2, 3 again, and 4 is 4. And 4 divided by 4 is 1. However, the answer is not 1. The answer is negative 5, 5. According to the answer key, of this package. Okay, entonces, what's the problem? The problem is that formula is not 100% effective. Sometimes work, and the majority is yes. You see 43 work. 43 is x to the 5th power minus 2 x to the 4th power plus 2 x to the third power minus 8 x to the second power plus x minus 2. It's obvious that the maximum coefficient is 8. It's this guy. And the leading coefficient is 1. Entonces the m es 8. Entonces the 0 is located between minus 8 and positive 8. Yes, this is exactly the answer of the answer key is this. Entonces, como es no 100% effective, I never put this in the test, okay? I put in the package because I want to illustrate this option you see in the book. So the question 44, 45, 46, and 47 is similar, but a little bit more interesting because you need to find the zeros bounded between one specific interval. For example, let's do it in the first. The first is, let's do in the first, so 44 and 45. Why I'm doing both together? Because it's the same equation, but different interval. For example, in 44, we have x cubed minus ax minus 3 equals 0, cubic equation. And the interval r, they call r, who is r? I don't know, the 0, maybe. Less than minus 3 and less than minus 2. This is 44. But 45 is the same problem, but the only thing it changed is the interval gets from -1 and 0. So the same equation, both problems. Okay. So now it's a little bit crazy. Start one by one. However, it's, you know, it's infinity possibility because we are talking about real numbers, not necessarily whole numbers, no integer number, no include decimal, irrational, something. So now the only possibility to do this is graphically using decimals. Of course, using decimal, and that way I want to explain now. Look, we copy the equation. So in the language of decimal, you put y equal or f of x either way, x cubed minus ax minus 3. And you open this curly bracket because this curly bracket indicates like a restriction, no? Is minus 3 less than or equal x less than or equal minus 2. Entonces, when it's the same equation, I copy in one line like that. In another line, I copy the same equation for different interval. Okay, it's -1 less than or equal x less than or equal 0. And you see, the reason that you are doing this is because, let me try to explain. This is my all real number line. Look. This is my all real number line. Yeah, I need to visualize only. Suppose that this is 0. This is -1, -2, -3, no? It's between -3 and -2. So it's a -3, it's a -2. I want to investigate this interval. And after I want to investigate, this is -1, this is 0. I want to investigate this interval. Yeah, I want to investigate the zeros. What means 0, 1? Maybe, I don't know exactly. When the cross, let me use another color, black maybe. This is the curve. This is the polynomial from graphic. Suppose 1 point here. I don't know exactly what happened here. 1 here. I don't know if it's in this shape or different. In decimal, you see clear. Let me show you. Let me share decimals, and you see super clear this. Let me try. Do you see that? We are doing 45 and 40, 44, 45. I put together, no? 44, 45. Look at that. Is this problem? Okay, I copy the polynomial. Okay, look at that. I copy first of all. I copy the original graphic. Look. Okay, but basically we have, you click on the graph. Do you see this, right? Yes or no?
Yes.
Yes. Look, this is 1, 0, 3. This is another 0, negative 0.382. And this is another 0 that is decimal. Okay, so now I want to see specifically, for example, this interval. Look at the coincidence, right? It's one piece of the green graphic. I put the black color. And you click here, click on the graph. And you see a small gray point, and you see this. And the answer is negative 2.618, no? And the package.
It logged me out.
Say again. You say something, miss? Come on, I need to understand what's going on. Help me. You see very well decimals or no?
Yes,
What was the problem? No problem, no?
I think someone accidentally unmuted themselves.
My voice was it muted?
No, someone unmuted themselves and they were talking.
I understand. Okay, so you see decimals very, very well. Okay, and you see the answer is negative 2.618. Actually, in the packet, the option A, I guess so, no? Is negative 2.62. You know, you round off to decimal place. And likewise, the other approximation, look at that. Again, we come back to the polynomial graphic, but I need to see now in between negative 1 and 0, bam, I'm using another color, and this is the piece case minus 0.38. 38.2, you trunk it in the 2 decimal place. Or not trunk it, round off, round down. This is clear, lady?
Yes.
Okay, this is fantastic. Remember, you can graphic no the entire real number function. So you know one specific interval, so you enclose the interval in curly bracket, right? Okay, this is 44 and 45. So I will stay in decimals because I want to see the same idea in 46 and 47. Gets another equation. Look, this is the equation. This is 4 degree. Oh, this is 4 degree. You see the aim behavior. This is not the problem that we need to talk about, but aim behavior, I take advantage. The aim behavior is right up and left up, no? Because of degree 4, this is even. However, I want to see one piece of this between negative 3 and negative 2. Oh yeah, in red color. Look at that. And you see, you click on the curve, you see the famous gray point, and the answer is negative 2.236, and the packet is negative 2.234. Is the option C. Okay. Likewise, we come back to the original equation, to the original graphic. So, and you see using another color, one specific interval is this. Ooh, this will look like complicated because I want to determine the 0 and between 2, not include 2, and 3. So, see, do not include 2, of course I don't care 2. I get this value que es 2.236 que you truncate into decimal place like a positive 2.24. Boom, that's it. Everyone follow me? No problema?
No problem.
Let's come back to the whiteboard. Because next problem, no, we don't need decimals. It's totally algebraically. Okay, there you go. Do you see the whiteboard?
Yes.
Okay. Okay, this is very, very, very important and very, very interesting. 48, 49, 50, and 51. And this problem, the information gets given is the degree of the polynomial, degree 3. So the degree is 3. And the zeros gets given, and the problem is one real que es -2 and one imaginary or complex, sorry, no imaginary complex, 3 plus I. But I need to know very well that when the polynomial is degree 3, we have actually 3 zeros. That's the first thing. The second thing is the complex is coming by pair of conjugate. Automatically, the problem don't say, but you need to understand that another 0 is 3 minus I. So we have basically the 3 here is 1 real and 2 complex. Cool? Now I need to find the equation of this polynomial. Okay, entonces you write in this format, que es a factory for x minus c1, x minus c2, x minus c3. Who is c1, c2, c3? This is 0. For example, this is c1, this is c2, and this is c3. Let's do it. I copy x plus 2, because remember the factor, you suppose always can have minus, but it's -2, double minus become positive. And you open big square bracket, and you copy x minus 3 plus I, que es the 0 number 2, and another bracket x minus parenthesis 3 minus I. Okay, and this would be the equation of the polynomial. Of course, is expressed in factory form. If they want you expand, but expand is too easy because the only thing you should do is multiplication, and that's it. You foil. I highly recommend that you are doing first the imaginary part. Okay, no, you can associate the property A times B times C. You can multiply A and B first, B and C after, or no, the product A and B times C. So the order is totally irrelevant. This is associative property. However, it's highly recommend do the complex part because you see always when you are doing the complex part, magically happen that the complex part disappears and you obtain a new polynomial with the real coefficients. Okay? Let's do it quickly. You focus it of the multiplication that part only, focus in that part. Okay, forget temporary x plus 2 get the real, que es easy. Entonces x times x, you foil, es x squared. X times that complex number, you consider like a package, is minus 3 minus I x. And minus 3 minus 3 plus I x plus, because minus and minus is 3 plus I multiplication 3 minus I. I don't know if you remember the easy way to multiply the complex number because they are conjugate. The shortcut is multiply this and this, 3 times 3 is 9. And this number get this number is 1. 1 times 1 is 1. And always plus in between. And the answer is 10. So you don't remember, no problema. You are doing like a regular student that don't know that rule. I want to do at least one time. And that's it. You don't know anything, you follow 3 times 3 is 9. Good. This and this is minus 3i. This and this is positive 3i's. This and this is minus I squared. Always happen when you are doing multiplication, two complex numbers, and they are conjugate, because the imaginary part is gone. And here we have 9, and you know very well that I squared negative 1 and double negative become positive. And the answer is 10. Do you see? This is the magic of this. So far, do you follow me? You
Yes.
have x squared minus, I distributed, why not? 3x plus ix. I distributed 3x and 3i. And the other part exactly the same, minus 3x minus ix plus 10. And this part, wow, disappear, cancel out. And so far we have x squared minus 6x. Now the easy part is the multiplication times x plus 2. This is not exactly FOIL because we have binomial 2 guys, 1, 2, trinomial 1, 2, 3. Therefore we have 6 combination, no? 2 times 3, 6. Okay, x times x cubed. I propose you multiply x times everything and 2 times everything. You know, it's one way to organize this. X times this is minus 6x squared. And this is plus 10. Now 2 plus 2x squared. This and this minus 12x plus 20. Entonces also we need to do something bilateral. Is x cubed minus 4 because it's minus 6 plus 2. Minus 2 because it's positive 10 and negative 12. Minus 2x plus 20. Oh, final answer. This is the answer. They correspond with the option A. Let me check it just in case I did well or no. Okay, A option. X cubed minus 4x squared minus 2. Yes, option A. Do you follow me? Was good or no? Clear? Confusing? What part confusing? Come on.
It's clear.
It's clear. Okay. Okay, now 49 is a little bit more complicated. Why? Because the degree form. Okay, let's try. Okay, let me try. And the degree 4, we have 4 0, include real and complex and repeated. In this case, not repeated. And the 0 is negative 1, 2 real. These guys are real. And 1 minus 2i is complex. And the complex, I know very well, is coming by couple of conjugates, 1 plus 2i. So actually we have 1, 2, 3, and 4 is exactly we need because the degree of the polynomial 4. Okay, this is the zeros. And the rest is expressed in factory form is x plus 1. Remember, we suppose always in the factor before is x minus 0. And double minus become positive. Now x minus 2. Bracket, the complete, I put the bracket. I don't know why. I like organize it this way. Is 1 minus 2i. Multiplication x minus 1 plus 2. Okay. And you can do, okay, be careful. You can multiply this guy. It's real. Easy for you. And this is not too easy, but it's similar to the other game we had doing before. Huh? Let's do the easy first. I like the easy first. X times x, x squared. X times minus 2 and minus 2x. 1 times x is positive 1x minus 2. Okay. Now it's x squared minus x minus 2. Okay. Yeah, at least I have this. This is a little bit more complicated, but let's do it. X times x is x squared. Let's separate. This time this is minus 1 plus 2i x minus 1 minus 2i x plus double minus plus 1 times 1 is 1, so 1 minus 2i, 1 plus 2i. I know that they are conjugate, and we have a shortcut to do super fast. This is 1 times 1 is 1, always plus, and 2 times 2 is 4. F5. Okay, no but. Now, distribute. X squared minus x minus 2i x minus x again plus 2ix plus 5. Okay, this is cancelled. All will happen, guys. Okay, the imaginary part is cancelled. So we have minus 2x minus 2x plus 5. And the rest is super easy. It's multiplication this and this together. For trinomial, and trinomial, we have 9 combinations. 9 combinations. I propose you, in order to organize this job, gets too long, multiply the first time everything in the second trinomial. So that's x to the 4th power. This and this is minus 2x cubic. Okay, I did that. This time this, and this time this is plus 5 x squared. Okay, at least I did the first time. Down. 3 guy and the second trinomial. Now let's move on to the second. Second is minus x cubic. Okay. Plus 2x squared minus 5x. And the last one is minus 2x squared. This is 2 guys, square plus 4x minus 10. Okay. Now who is lie? This is a cubic, this is a cubic. So you go with x to the 4 alone, minus 3x cubed. This is a square, and a square. Oh, but this is cancelled out because it's the same value with the opposite side, 5. So 5 x squared. Well, who more is lie? Well, it's like this. It's linear is minus x. Because of negative 5 plus 4 minus 10. End the story. Final answer. Okay. And this is in the package of the option C. Option C. X to the 4th power minus 3x to the 3rd power plus 5x cubic. We know square minus x minus 10. Cool. Option C. Not bad? Too long, no? That was 49. Now 50. Oh, 50 is easy. Why is easy? Because the complex guy are purely imaginary. And the real part is 0. So we have again, one more time, the polynomial degree 4 but the information gets given is that the zeros are 4i and minus 5i. And this guy and this guy are purely imaginary. I know que the complex is coming by couple, entonces the conjugate is minus 4i and the conjugate is positive 5i. In total we have 4, 1, 2, 3, 4. No real, 0 real, 4 complex, and pure imaginary. So you copy the format, you know very well, this x minus 4i, x plus 4i, x minus 5i. The order is not important, but you, of course, you combine the couple, no? 4 and 4 and 5 and 5, no? Well, it's, you know, more efficiency, more comfortable. But the product is either way, you get the same answer. When you are doing the multiplication of these, it's obvious. Let me show you. This is x squared plus 16. Yes or no? Yes or no? Let me try. But you need to know quickly. Okay, let's do the multiplication of x minus 4i times x plus 4i. This is x times x is x squared. This is plus 4 xi. In this order, this is minus 4 xi, and this is negative 16i squared. Okay, this is cancel. Again, one more time, the same idea gets conjugate. But negative 1i squared, negative 1, and negative 1, and this one we have give me x squared plus 16. Wow, fantastic. And these two factors together is x squared plus 16. So in conclusion, guys, you are super familiar when you are doing the difference of a square like that. The factorization is xx 4 plus or minus. Yeah, I say one day that the sum of the square is prime. Or is prime in the real field. But as you're extending in the complex field, you apply the same formula. Xx, but now we have 4i plus or minus. Okay, is if the question say factorization using linear factor. Linear, remember, is degree 1. Break it down, and linear is x plus or minus something. Likewise, the second factor would be x squared plus 25, no? Because 5 times 5 is 25. Now the rest is super easy. You are doing FOIL. Doing x squared times x squared, x to the 4 power. X squared times 25 is 25. X squared. 16 times x squared is 16x squared. And 16 times 25 is 400. And we combine later x to the 4th power plus 41 x squared plus 400. And this is the polynomial that satisfies this condition. Degree 4 and the 0r, 4i, and negative 5i. I get the option D. I guess so. That's position.
Yes.
Mm-hmm. Okay, we have another similar. 51. 51, 51. Okay, 51. The polynomial is degree 4 again. Okay, and 2 0 real is given. Zeros are positive 1 and negative 1. And 1 complex. Pure, no pure. Complex contain real pocket 4 and imaginary pocket 2. You need to know by concept that another 4 0 is 4 plus 2, que es igual. You set out then, this is x minus 1, corresponding with this 0, x plus 1, corresponding with this 0, bracket, x minus 4 minus 2i, multiplication, x minus 4 plus 2. Okay, this is the factor 4, but they want expand 4. Okay, but let's do this. It's too easy. Wow, this is x squared minus 1. Yes or no? Apply the formula of the difference of square root of Bauer. Okay? But normally, this formula, okay, you know very well, we apply in that direction. In that direction, because you want to factorize. Factorization. But we can apply in both directions, like in multiplication. Actually, entonces es minus in the middle, and square refers as x times x, and 1 times 1, no? Is negative 1. And what happened with the last outer and last is cancelled. If you want, I do for you. Pero no, it's shortcut. Which way? Suppose that you are doing by hand x minus 1 and x plus 1. This is x squared. This is x1, 1x, minus x, minus 1. To cancel and stay x squared minus 1. Okay? Now, similar, x squared. X times this is minus 4 plus 2i x. Okay, now inner is minus 4 minus 2i x. And plus, because negative and negative is positive. And the multiplication, let me see, is 4 minus 2i, 4 plus 2i. If you want, you copy here separately to compute that in detail. But the shortcut is easy, is 16, always plus unbelievable 4, is 20. The answer is 2 times 2 is 4. It's 20, yeah, it's 20. So actually, we have x squared minus 4x plus 2ix, 2 plus, no, minus. Be careful with the sign. One sign that you are doing wrong, you don't get the final answer. Minus 4x again, plus 2i, 2ix, sorry, plus 20. Okay, this is cancelled. Always expecting the imaginary part is cancelled. We have minus ax plus 20. Now multiplication this and this. We have 2 and 3 is 6 possibility. Is this and this is x to the 4th power minus ax cubed power plus 20x squared. And the one is super easy. It's minus x squared plus ax minus 20. Well, the only possibility to combine later is this, because 20 minus 1 is 19. And this I suppose que es the final answer. Que corresponde with the option B. Let me check it. No, option B no. Option B no. Option A no. Option C, yes. Options no. Es D. A ver, 8 to the 4 power minus 19 es D. Es D. Any question? Do you understand very well this or no? Okay.
Yes.
Yes.
One question of this you see in the test. Okay. Now 52, 53, 54, 55, 56, and 57 is practice. Find all zeros of the functions and write the polynomial as a product of linear factor. Oh, linear factor. Okay, let me erase everything. Try to find the last page. Okay, wow. Last page. Last page, I suppose it's this, page 10. Okay. Page 10. What is the job? Well, the job is you try to factorization. Of course, using every tools que you know. The classical factorization, que I know is always good, but it's weak. And scientific division maybe. And why no? Quadratic equation. Everything. Because we have in our hands factorization classical. Maybe you solve the problem, maybe no. Scientific division, que fantastic. And in the last part, we have quadratic equation, maybe see somehow involve imaginary number or complex number. It's not too easy to see by hand, to say, bueno, by hand, but using quadratic form. Let's try. 52 is easy. It's x cubic minus x squared plus 16x minus 16. Wow, in this case, super easy because you apply factorization by grouping. This couple and this couple. The gray common factor in the first couple and the red couple is x squared. You have x minus 1. And the gray common factor in the purple color couple is 16. Is x minus 1. Wow, fantastic. I like that because x minus 1 is here and here. Therefore, I factor out one more time x minus 1 out and stay x squared plus 16. Okay, But they don't want like that. No, no, no irreducible quadratic. No, 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 no. They want linear, linear. This is the key idea, linear factor, degree 1. Okay, so this is complex or imaginary, I know, but you separate in two. This is square root, this is x, and this is for I, plus and minus. Bang, final answer. Option A, I guess so. Do you follow me? Do you follow me? Do you follow me? Do you understand these linear factors in complex field? Yes or no? Guy, I talk to you, no? Answer me. Do you hear me or not? Yes. Okay. Yeah, it is yes. Okay. Yeah. Joshua. Okay. Okay, this was easy. And the other no. The other is a little bit complicated. Remember, the idea in this problem is factorization, find all zero, and write the polynomial as a product of linear factor. Okay, this is x cubic plus 11 x squared plus 36 x and 26. Okay, cool. So I see, I immediately I go to the small. Okay, in this one I can see, okay, at x equal -1 is a zero of this problem. Then the factor x plus 1 belong to this factorization. However, to prove that, and to continue next step, you are doing scientific division. 111, 36, 26. And you come here, -1. Bring down 1, multiplication of -1, this is 10, multiplication of -10, this is 26, multiplied by -1 is -26, 0. To prove que this idea que I see in Desmos is true, but the 0 is a -1 and the factor is x plus 1. Okay, now, to verify this equation, que es x to the 0, x to the 1, x to the second, que es actually x squared plus 10x, 26. Well, you apply discriminant or go directly to the quadratic equation in which A1, B is 10, and C is 26. When you apply the formula minus B plus and minus square root B squared minus 40C divided by 2. In our specific example, is minus 10 plus and minus square root 10 squared minus 4 multiplication by 1 multiplication by 26 divided by 2 times 1. So we focus in the expression inside the radical. Okay, and this is 100 minus a multiplication is 104. Now subtraction is -4. And you apply square root. It's 2i. So far we have minus 10 plus or minus 2i divided by 2. You can simplify a little bit because 10, 2, and 2 are even numbers, no? You divide by 2 everything. It's actually -5 plus or minus I. Now, how you write the factorization using linear factor? Well. I know that the first factor in the game is x plus 1. And the second factor in the game is x minus 5 plus I. And x minus 5 minus I. You can leave it like that, you can, but more elegant is x plus 1, parentheses, no bracket, remove this parentheses, is x plus 5, because minus and minus together is positive, minus 5. And x plus 5 again, plus 5. Oh, elegant answer. 3-factor linear, 1 real, 2 complex. Give me, when you are doing the multiplication, is polynomial. Okay, the option, we see what option is correct, is 8. It's 8. The option. Everyone's clear?
Yes.
Okay. 54. Let me ask something. Do you see the link I sent to you of the Desmos script?
Yes.
Excellent. Was good?
Yes.
54. 54 is x cubic plus 8x squared plus 24 x plus 24 again. Yeah, I see in Desmos, because it's the first thing you should do, verify in Desmos. Okay, we have T1 degree 3, and we have x equal minus 2 is 0. Minus 2, minus 2, minus 2, minus 2. No, minus 2, minus 2. Okay, corresponding with the factor x plus 2. Okay. Now let's do in the scientific division to separate the real part and the complex part. Maybe, I don't know. Entonces es 1, 8, 24, 24. And you are doing the scientific division using negative 2. Bring down 1, multiplication is negative 2, this is 6. Multiplication is minus 12. This is positive 12, and positive 12 times 2 is minus 24. Guys, are you aware when you get 0 remainder, it's because x equal minus 2 is 0, and the factors is x plus 2. And we have the equation part is x to the 0, x to the 1, x to the second is x to the second plus 6x plus 2. I believe is complex. One super fantastic way to verify quickly is compute the discriminant, but no, I want more, because I want to factorization using linear factor. Therefore, I need to solve in the quadratic equation. A is 1, B is 6, and C is 12. My formula is minus B plus or minus square root B squared minus 4AC divided by 2A. Our specific example is minus 6 plus or minus square root 6 squared 36 minus 4 multiplication by 1 multiplication by 12. Everything inside the radical, 2 times 1. So we're using different color. I compute that part, get 36 minus 48. So 4 times 12, 48. When you're subtracting, give me 12. Minus 12, minus 12. Let me erase that part. C is 12. This is minus 12. And now I need to find the square root. Is, you know, is I square root 12. Well, 12 I can simplification a little bit because 12 is even, and we have a couple of 2 that we can put outside the radical. Like 1, 2, actually is 2i radical 3, and these 3 stay inside the radical. And so far, the answer is minus 6 plus or minus 2i radical 3 divided by 2. One more time happen. Okay, the coefficients are even number, so you can divide by 2. So it's minus 3 plus or minus I radical 3. Because actually the thing I did was split these 2 here and split these 2 here. This is 6 divided by 2 is 3. It's minus 3, no? It's minus. And this is plus or minus 2 divided by 2 is 1. Okay, ready. Now, what is the factorization using linear factor? Well, the factorization equivalent 100% is x plus 2 bracket x minus 3 plus I radical 3 plus the bracket, another bracket, x minus 3 minus I radical 3. Perfect. However, it's too long, no? To say now, I'm going to simplify a little bit more is to remove this innermost parenthesis. And now the bracket becomes like a parenthesis, x plus 3 minus I radical 3. And x plus 3 again, negative, positive, and positive again, I radical 3. Okay, the answer, the factor form, using linear factor and complex, get the option is easy, B or D. B with D, I don't know. B with D. I suppose, well, no. No, because it's positive. It's D, no?
D.
It's D, yeah. Thank you. Who are you, miss?
Jenny Macy Rodriguez.
Okay, not bad. I understand very well. Let's move to 55. 55. Well, 55 is easy because it's x to the 4th power plus 34 x to the 2nd power plus 225. Unfortunately, when you put in decimals, you don't see nothing. And the reason that you see nothing is because any factor are imaginary or complex. Now, let's do it in an easy way. This is a trinomial. Why not? Let's do a factorization. Square root x to the 4th power is x squared. I need to find the combination that open the door. Okay, 25 and 9. You multiply 25 and 9, get 225, and 25 plus 9 is 34. The combination is 25 and 9. Doesn't matter the order. 25 and 9 plus everything positive. And leave it like that? No, because this is quadratic, irreducible, and the real field. But in the complex, separate a linear factor x. Is linear because the exponent of the variable x is 1. And this is 5i. Some matters. This is 3i. Some matters. Final answer. Option C, no? I guess so. No. Sí, sí, sí. Sí. That was easy, eh? The problem is,
Yes.
yeah, the problem is investigate. Okay, so at the beginning you don't know anything. You put a polynomial in decimals, and you see that we have no zero. Wow, the zero is missing. It's missing in real. Because remember, in decimals, you see two-dimension plane x and y, where both axes, x and y, are real. This is all real number, and this is all real number. That is the reason that this is r squared. See, we have the zero in another dimension you don't see. When you don't see something, it's because it's complete or imaginary. So now I need to use my imagination. What is my imagination? Well, scientific division, I don't know how I start because I have no idea. But fortunately, it's trinomial. Yeah, I try to do my best in the factorization of trinomial. Okay, let me see 56. 56 is 56 x to the 4th power plus 2x cubic plus 6x squared plus 18x minus 27. Let me see if I copy it right. Yeah. Just I go to the smallest. In this I can see that at x equal 1 is 0. That represents the factor x minus 1. And also at x equal minus 3 is also 0, que represent the factor x plus 3. At least I have two factors in my hand. To obtain the two next, que maybe it's complex or no, I don't know, we perform scientific division. 1, 2, 6, 18, negative 27. The order is not important. I start always for the easy, que one. Bring down 1, multiplication is 1, this is 3, multiplication is 3, this is 9, multiplication is 9, this is 27, multiplication is positive 27, and remain the 0. Now confirmation, x equal 1, s is 0, and the factor associated with this 0 is x minus 1. Now I try negative 3. Bring down 1, multiplication with negative 3, this is 0, multiplication is 0, this is 9, multiplication is negative 27. 0 remain again, happy. The next 0 is negative 3. Exactly we see in decimal. This is the verification of decimals. And the factor associated is x plus 3. Well, the other factor is, this is x to the 0, x to the 1, x to the second. Actually is x to the second plus 9. Always complex because it's irreducible quadratic, one point of view, another point of view is sum of square, que always say prime, but I know that the factorization is x, 3i plus or minus. So the total factorization, this trinomial expressed like a linear factor is 4 parentheses 1, 2, 3, 4x, 1 negative, 3 positive, 3i positive, and 3i negative. These and these are equivalent 100%. And represent the option C, I guess so. The last one. Wow, look like unbelievable. We finished the super fantastic review. I always try to do big review. We consolidate very well. I know that this subject is hard. So that I dedicate time to redo again. Okay? Because our lecture is too long, no? Okay, last one. The last one is 3 to the 4th power minus 4 x cubic plus 27, 28, sorry, x squared minus 56 x plus 9. Okay, again, one more time I put in decimals because I'm lost. It's too complicated guessing. No.
I think it's minus 36x.
Oh, let me see. Oh, yeah. Not 56, 36. Thank you. What's your name, Mister?
Edward?
Edwin. Yeah, I put a weird 3, I believe is 5. It's not 5, it's 3. Okay, entonces en decimals, give me information que add 1, que the factor is x minus 1 is below. And x equal 1/3, que is equivalent to say x minus 1/3. Okay, let me try. Scientific division. 3, negative 4, 28, minus 36, and 9. I start for the easy, get 1. Okay, bring down 3. Multiplication is 3. Negative 1. Multiplication is negative 1. This is 27. Multiplication is 27. Positive. Subtraction is negative 9. And negative 9 times 1 is negative 9. 0 remaining. Cool. I prove here in that piece that the 0 x equal 1 and the factor of x minus 1 belong to this polynomial. Okay, now let's try 1/3. 1/3 positive, no? 1/3. Both are positive. Bring down 3, and 3 times 1/3 is 1. No, negative 1 and positive 1 is 0. Multiplication is 0. So 27, and 27 divided by 3 or multiplied by 1/3 is the same. It's positive. It's 0. That means I verify that x equals 1/3, that the factor is x minus 1/3 below. And the rest is x to the 0, x to the 1, and x to the 2nd. Expression is 3, x squared plus 27. Wow, this expression has a common factor that is 3, and it stays x squared plus 9. And this 3, why not multiply by this and become like a 3x minus 1. So this 3 get inside this factor, multiply 1 times 3 is 3, and 3 times 1/3 is 1. It's more elegant. You can do in either way, but this is the elegant one. And finally, this is irreducible quadratic, and the linear factor is x 3i plus or minus. Okay, so what is the final answer? The final answer is one factor is x minus 1, another factor is 3x minus 1. They are real, and two complex or imaginary, que es x plus 3i and x minus 3i, que corresponde with the option B. I guess so. Super clear?
Yes.
How do you feel about this?
Confident.
Because every test would be like that. We explain the theoretical part, but we have time, at least 2 lectures, to review everything. And the time that we have, let me try to explain at least the first part of the chapter 3. Que es super easy, it's no big deal. Of course, involve some new concepts. So chapter 3, guys, is about transcendental functions. What means transcendental? Transcendental means, for example, so far we studied the 2 classical functions we studied was polynomial and rational. Polynomial and rational get the division to polynomial, no? And transcendental is a history name, is beyond, o sea, transcend to the polynomial and rational. It's a new functions. Okay, so we study different functions. let me try to see at least the name of this function we studied in this chapter, que es exponential function and logarithmic function. But okay, and I want to study the relationship and between this function, the different property, and finally, as always, you finish with the application and the real life of these functions. But first of all, we need to study mandatory. One topic is called a one-to-one function. One-to-one function. And we put semicolon, no and. Inverse function. Okay, this is super important, super important. And it's extending beyond this subject. You study calculus, trigonometric, you see this idea. Okay, entonces let me recall functions. Recall function we studied in the chapter 1. In the chapter 1 we studied, for example, we have different possibilities. Let me try to write quickly 3 possibilities. This circle, or no circle, ellipse, something, indicate domain and range. Okay, in different situations. Okay, I want to select at least 3 values, bam, bam, bam. I want to call hypothetically x1, x2, x3. So our domain is only 3 elements, case x1, x2, x3. And the range is 3 elements also, y1, y2, y3. Let me copy here, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and the same name. I want to stay a relationship in between association, this and this, for example, this and this, and this and this. Okay, the arrow indicate function, is associate. In general, no function, relation. But one more specific is a function when you have only one guys here. So one, each value here is associated with it. This is a typical one-to-one. This is a typical one-to-one that we study in detail now. We have another possibility is many-to-one. Okay, for example, is this associated with this associated with this associated with this, and this is stay alone. This is many-to-one. And we have one-to-many. In which, for example, this is associated with this and this, one-to-many, no? And the other is not important. So, we studied in detail that one-to-many is no function. Because fail the definition, no? Of the function is each value in the domain is associated with the only one value in the range. This is yes, and this is also yes. You follow me? Everyone follow me?
Yes.
But I want to discuss the difference between this yes and the difference between this yes. Suppose now I try to investigate inverse function. What is inverse function? Well, inverse function is the same function but in opposite direction. So I change the arrow. And the symbolic way to indicate inverse function, symbolic, is the same name of the function SF, but using like a -1 exponent, but actually it's not -1. It's totally symbolic way. So don't imagine never that f -1 is 1 over f. No, no. No reciprocal. It's inverse. It's inverse. It's a notation que create the mathematicians. It's not my fault. Okay, so now we have different example. We have this you study now here in the trigonometry, for example, sine function, but we study sine inverse function, que es sine inverse function. This is the inverse function. But what is the interpretation? The interpretation is the same idea, but you interchange domain and range. So in the inverse, you switch, you swap. But the idea is clear. The idea is super easy. Look, the idea is you interchange x, y, you interchange. This is the idea. Swap, interchange. And this is f inverse. Now what happens if the function is many to one? Oh, we can't know. Why not, professor? Because you change the direction of the arrow, the function inverse is now one to many, que es no function. Therefore, by the conclusion, one of the conclusion is the inverse function que you suppose hypothetical do not exist. There are reasons in which you can enforce in the situation to remove do not, but this is not important now. Okay? You make a restrictions in the domain to create a yes exists, but in general no, do not exist. Entonces, what is the important conclusion in this topic? Oh, the important conclusion is to exist the inverse function mandatory, the function would be 1, 2. Okay, entonces now any problems that we have about inverse function, the first step is prove somehow that the function is 1, 2. If the function is 1 to 1, yes, the inverse exists, I can find. And this is challenging now. Find inverse, find inverse, find inverse. Do you understand the idea? It's mandatory to be 1 to 1. Okay, professor, but what is the how you investigate that? Because using the arrow, domain, and the circle is easy, but no, in the real life we have functions. Well, to say now you apply one test, que is called horizontal line test. Okay. I suppose you remember vertical line test, yes or no? You remember?
Yes.
You remember. And the vertical line test is using to what? To verify what?
If it's a function.
Exactly. Si es a function or no. So this test allow me determine if the function is no function or yes, it's a function. This is the vertical. And the horizontal, I suppose that you pass the vertical line that is a function, but you need to see more. See that function is 1 to 1 or no. Or no 1 to 1. Si es 1 to 1, entonces the inverse exists. Entonces, what is the idea? The idea is super easy. Look, let me show you a different example. Suppose the classical parabola that we're working every day in transformation. And suppose also, why not, this is y equal x squared. Suppose the cubic function is something like that. Y equal x cubic. By the way, this function is even because it's symmetric with respect to the y-axis, and this is odd because it's symmetric with respect to the origin. But this is not the point now. The point now is that you apply one hypothetical horizontal line, because the name of the test is horizontal line. Si cross in one point, yes, a one-to-one. Si cross in 2 points or more, no, no one-to-one. No one-to-one. And it's yes, is one-to-one. The thing I try to explain is that sometimes we need to be one-to-one. Okay, no problem. Entonces we can make a restrictions in the domain. For example, professor, pero it's a shame que the parabola have no inverse function. Okay, yeah, but this is under the supposition that the domain is a real number. Actually, the domain that we study in your moment when you study the quadratic. But suppose I make a restriction in the domain, and the domain is no all real numbers, it's only the positive part, so include 0 to infinity. So now my graph look like that. It's a half of parabola. But this function is not 100%. It's the same equation. Okay, some students believe that if the equation is the same, it's the same function. No. The important thing when you define a function is 3 pieces. Equation is important. Same equation, yes. But same domain and same range. In this case, domain and range is different. Domain is only the positives are non-zero, and the range is non-zero. And this function is not equal to this function. However, when you apply the horizontal line test, pass the test because crossing one point. Okay, so the way to indicate this in the problem is very, very confusing. Is you define the function and you put semicolon, 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 and you put x greater than or equal to 0. So the student says, well, professor, what the hell is that part? Well, this is the domain. See, you don't specify anything. Default, you suppose that the domain is all real number. This is the supposition. In this case, since this is our function, so default, I don't write anything here intentional to confuse the students. And the students say, no. This function is no one-to-one. This function have no inverse. However, this, yes. Another version, maybe you define the negative part, another half of parabola, entonces now it's one-to-one. Do you understand very, very, very well or no? So two important ideas. Requirement number 1 to have inverse is that my function would be one-to-one. Another conclusion in that part is, well. It's obvious that if you are doing this action, interchange x and y, it's obvious that the domain of the original function f, I want to call original f, and the inverse is original is f, and inverse is inverse is f negative 1, and the range of the inverse function is the same, or the range of the original is equal domain of inverse function. This idea is clear? It's very, very clear graphically when you see this idea. My function f is the arrow in purple color. This is the domain. And this is the range. Now, I'm switching that. This is now domain for the arrow in red color, and this is the range. Okay. So the action to switching to interchange x and y give me the interchange also domain and range. Es obvio, ¿no? Ok, entonces one fantastic property que is not clear to see, but in the example you see more clear. So you are doing the composition. Suppose you have composition. When you study composition, this maybe is not 100% clear. You have two functions. Function f, composition, function g. This is a symbolic way to indicate this idea. Look, f is the outermost function, and g is the innermost function. Okay. This is the composition. Composition what? Composition two function. And this order, okay, by the way, so you interchange the order, put g outside and f inside. It's another composition, but this is not equal. Well, not always. Entonces, there are some particular examples in which is the same. So in general, the thing I try to explain is, in general, f composition g of x is not equal g composition f. No. But in particular, yes. And this is the case that we study now. The particular in which you, for example, you are doing the composition f inverse. Okay, if you are doing in opposite direction, f inverse composition f is the same, and it's logical because, for example, you have domain and range. And you have one value of the x, give me one value of the y in this direction. This is f. And when you are doing the inverse, let me try to do here. Actually, it's the same line, but in opposite direction. We come back at the beginning, right? And so the answer is the inverse. When you are doing the composition, this and this, well, you are doing nothing. This function undoes each other. Give me x. It's identity function. Wow, identity function is nothing. It's the same value. Okay, great. To understand this is easy to understand. In the example, suppose que one function is addition 1, 10. Y I suppose que the inverse function is subtracting 10. Yes or no? Because somehow, going back. Okay, suppose one value. Suppose f evaluate f5. 5 plus 10, 15. No? However, si you are now evaluate and 15 minus 10 f5, and we come back to the same value. Okay, entonces this is super important, and this always happen. I put the example for the addition and subtraction, but there are many examples, elementary, no big deal to understand inverse function. Maybe it's multiplication and division. Maybe it's a square root and a square. And we study in general. A hypothetical example, I give one function, hypothetical function, you prove somehow that this function is one-to-one, therefore exists the inverse function, and also you find the inverse function. Okay, in general, this addition and subtraction is elementary. You can get example to understand the idea. Multiplication and division, square root, but they are complicated problems what involve more complicated equations, but it's okay. Do you understand so far? Theoretical part.
Yes.
Let's move on to example. Let's do a couple. And that's it. And that's it. Too much, eh? Too long class, eh? Remember, the advantage is, this is for good students, no? Okay, you take 2 classes in 1 semester. Suppose the function f of x equal x cubed plus 3. This is my first example. Wow. What should I do, Professor? Well, you are doing 5 steps. Step 1 is verify if the function f is one-to-one or not. Si the answer is yes, we keep going to step 2. Si the answer is no, well, entonces you stop or you make a restriction to pass the famous horizontal line test. Okay, the second step is always classical. You take the before this, you find, this is the most important step, step 2. Find the inverse function, the equation associated with the inverse function equation. I want to explain how. Step 3 is checking. How you check it? Well, easy. You take the original function, composition inverse, is equal inverse composition f is equal identity function. We are doing both directions. Step 4 is domain and range. Determine, no? Determine. But determine what? Domain and range of who? Of both. Of the original and domain of the inverse and range of inverse. So we have 4 sets, 2 domain and 2 range. Okay. And that's it. Well, almost. The step 5 is do the graph. The graph of what? Of both f and f inverse. And you see the fantastic property of this graph. Okay, it's important we are using in the future for the transcendental function. Okay, just the 5 steps, sorry, too much, too long. That's okay. Okay, number 1 is determine, verify, say one-to-one. What is the only tool we know to verify this? What is the only possibility? Okay, you have to verify if one function is one-to-one or not.
Look at the graph on Desmos.
And do the graph in Desmos, I agree, and suppose I have the graph. What
Or
should I
end behavior.
No.
No.
Okay, what is the test? Okay, I explained today to verify if one function is one-to-one or no.
The horizontal line test.
Exactly. You apply In this graphic, you apply in Desmos, horizontal line test. Of course, if you pass the test, it's 1-to-1. Si do not pass the test, it's not 1-to-1. Pero no necessary Desmos, because I know very, very well at least the most basic function, suppose cubic function, graph without Desmos, without Desmos, look like that. Yes or no? Cubic function. Y equal cubic. And however, this is a family of these because the only thing I did was +3, and +3 is a transformation. Yes or no?
Yes.
What kind of transformation?
3 up.
3 up. It's a vertical shift, 3 up. Very well. So it's the same shape. It's the same shape. The only thing that's different is que es 3 up. This is x cubed +3. At this point, normally is 0, 0. Now would be 0, 3. And this is my x, and this is my y. What do you think it happened? Pass the horizontal line test or fail?
Pass.
Pass. Es obvio que pass. Any hypothetical horizontal line, cross, and only one point. Pass. Horizontal line test. Therefore, this function is 1, 2, 1. Okay, let's see 1-to-1. You have inverse or no?
Yes.
Yes, we have inverse. And now let's move on to the step 2, que es find the equation for inverse. And the teacher explained que the inverse is like a opposite, no? Addition, subtraction, multiplication, division, square root, and square. But in this specific example, it's not square, it's cubic. So what do you using intuition? Intuition, maybe the intuition not necessarily work. But using intuition, the action that we are doing in this, when you plug in one value of the x inside that function, you raise to the cubic power, and this result you add in 3. So you are doing Bauer. What do you suppose is the operation? What is the inverse operation? You are doing 2 operations. Raise to the 3rd power +3. Power is in the opposite direction. No idea.
Is it a cubed root -3?
Exactly. She say something. Intuition is cubic root and subtracting 3. No addition 3, so no subtracting 3, right? But it's, I don't know. You have 2 possibilities. The inverse function, intuition, guy. I want to explain the systematic procedure to find the equation. Nice. But intuition would be like that, or would be like that. What do you think? Is the first option or is the second option?
The second one?
The second one. No. Let me try to understand why not. Because we are doing the same operation but backward. The order and the original was cubic first. Cubic. And second was add 3. And inverse, then we are doing exactly but in the opposite order. So we start here. This is step 1, is subtracting 3. And the second step is cubic root. Make sense? Make sense or no?
Yes.
But okay, don't worry too much for this. Because the fantastic procedure to find the equation for inverse is you copy again my function is giving in the problem. But the only thing I did was replace f of x for y. But you know very well that f of x and y is the same thing, right? But the only advantage and disadvantage is que es function notation. And function notation sometimes is useful to see transformation, to see formulas, etc. Now, in this, que es the original, exactly the same, equivalent, 100%, you interchange x and y. This is the key idea. This action, you put x here, y cubic plot. Do you see the idea?
Yes.
Voila. In this moment, this is the inverse. But what's the problem? The problem is que this inverse is expressed in implicit form. What mean implicit, explicit? I don't remember this name. Explicit or implicit form. Well, implicit is a little bit crazy. It's when the x and y is mixing together. Suppose capital F, x comma y equal constant. Is when the y is not isolated. Explicit is clear, super clear, and you isolate y alone using algebra. So now, never leave it like that. Not good. I did that, but nobody understand. Now, you transform this. I try to isolate the y. So you subtracting 3. You apply cubic root both sides. Now cubic root x minus 3 equal y, and this new y is the inverse function. Wow. Okay, then my conclusion is equation for inverse is cubic root x minus 3. Cool? That makes sense, right?
Yes.
We did step 2. Let's move on to the step 3. 5 steps you should do in any problem of this in the test. Okay, guess verification. So you put together, you are doing the
Are you still in class?
Yes. Why not? Why? My class is extending to the 11:20, no? Ah, sorry. It's somebody, no? Who talk? Who speak? It's your family, no? This is the thing in the online class. Okay. Put the microphone off, please. And you don't forget to put it off when you finish to ask me any question. Okay. Now. Okay, what is the next step? I forgot. The checking. The checking is easy because you put together the original function, composition is inverse. In either order, guy, f composition f inversa, doing in one line, f inversa composition f, we are doing in the second line. So now, what is the interpretation of this? Remember, the innermost function is this. So actually, the action is you take this, get the inverse of this, and you replace for x here. So is, let me try to do my best. Is instead of x, you copy cubic root x minus 3 cubic. Okay, this 3 is this power 3. You understand the thing I am doing or no? Do you understand or no? Hey. Wow. Do you hear me, guys? Or no?
Yes,
Yeah.
I kind of understand a little bit.
Ajá, entonces, yeah. So you understand the thing I do. Okay, entonces, let's do it. Algebra. What happened? QB root and QB power cancel out each other, no? Chum, chum. We have x minus 3 plus 3. Oh, and x plus 3 and minus 3 is 0. And the answer is x, because this is the identity function. Identity function is a little bit stupid. It's a function que si the x value is 1, the y value is 1. Actually, it's the line like that, no? 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2. This is the identity function. And the interpretation is que es identity because all those each other. So the action, the mathematical action of the inverse inside, because the direction is inside the original, on those. We are doing nothing. It's identity. Let's do it in opposite direction. Let's do it in opposite direction. Let's do it in opposite direction. Opposite direction is now F inside F prime. In other words, is this expression que es F. You move, and replace for X here. Entonces, basically is QB root. No X anymore. No. It's X QB plus 3 minus 3. You understand the thing I'm doing? The thing I'm doing was you replace in the inverse against X for the entire expression X cubed plus 3. One more time having it, positive 3 and negative 3 cancel out, and cubic root X cubed is identity function again. Super cool, work. I guarantee that this worked perfectly. The equation that we found is good. It's the inverse function. Okay. I like so much this. Do you understand? Do you follow me?
Yes.
The step number 4 is domain and range. I want to do one example, only one example today. This example to complete it, and that's it. What do you think about domain of F? I want to copy F again. So we try to do a step 4. What is the step 4? Well, we determine domain of the function F. We determine the range of the function F. We determine domain of the function inverse, and we determine the range of the function inverse. Okay, let me try. Look in the graph. Look in the graph. Que I did, no? But I erase. Remember the graph. The graph que I did was something like that. XY. And the graph of the inverse was something like that. I suppose you remember. And this famous point is the point 0,3, no? Okay, domain. Domain is, well, there are many points of view to see domain. You see graphically or you see. Remember, domain, the supposition always is all real number except the restrictions. And the restriction we have in different situations. Situation number 1, denominator non-zero. Situation number 2, square root non-negative. And they are combination. But in this example, we have no division, no rational, and no square root, it's cubic root. And cubic root is nice. Therefore, and actually, my original function is polynomial, ¿no? Degree 3. Entonces, Es obvio que the domain is a real number. Do you see this one?
Yes.
Automatically, this is equivalent 100% to the range of the inverse. It's the same, guys, in opposite direction. And the domain of the inverse is, bueno, es a cubic root. Pero cubic root allow us inside the cubic root negative number, no? It's no imaginary. Ay, no. It's negative 3, for example. Si es 27, no? So negative 3 times negative 3 times negative 3 times is negative 27. Therefore, it's again all real number. Only we have restriction when it's a square root, or not exactly square roots, you know, any root whose index is even number, and the root the index is odd number is all real number, definitely. Okay, cool. Entonces we are doing step 3, I did that, and step 4. The last step is the graphic part. But the graphic part, I want to take advantage of the decimals. But wait, let me try to explain. I remember that one student say that the transformation, okay. Let me try intuition first. Intuition, and after we see in decimal, and that's it for today. Some students say, well, professor, we have two basic graphics. The graph of the function y equal x cubic, and the graph of the y equal cubic root. Somehow it's connecting by this function. But in this case, plus 3. And the situation is like that. Vertical shift, 3 units up. Oh, but in this case, minus 3. This is minus 3 inside. It's like, you know, f of x plus 3. And this is f of x minus 3. This is vertical shift, clear like a water, 3. But this is horizontal. Yes or no? Because it's inside the parentheses. In what direction, guys? To the right or to the left?
To the right.
No. Yeah, right. To the right because it's negative, yes. So now the graph, I forgot to say that, the graph of cubic root, I don't know if you remember, look like that. It's similar to this, but completely rotate 90 degrees. Now, see, you put horizontal shift 3 units to the right, okay? So we have this curve look like that. Look, let me show you. And this famous point, okay, this case is 0.3, and the function, this is the original function, and this is the inverse function, would be 3.0. And it's logical, because the action we are doing is this. You interchange any point by point, x and y. X is 0, y is 3. Now, y is 3, x is 3, sorry, y is 0. And this is the easy way to do the graph point by point. However, in decimal is easier, no? But the important property is that these graphs are symmetric with respect to the line y equal x que represent the identity function. That distance, guys, and the distance is the same. So the easy way we are doing so far to do the equation and to do the graph of the inverse function is this symmetric with respect to the line y equals x. Okay, no more blah blah blah. Let's see in decimal one example at least, and we continue next time. All right, let me see decimals. Okay. Okay, save. And now, wow, inverse function. Cool. Okay, let me share the screen with the decimals. Do you see decimals?
Yes.
Okay, look at that. This is example 1. What the hell? Look, this is the pam pam pam. Different point. Okay, pam 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 pam. Look, this is my original given function. I put in black color. Okay, the important point is 0.3. Okay, and 1.2, negative 1.2, sorry. And this no. This no. And this is 1.4, I guess so, 1.4. At this point belong to the region. Okay, now I'm going to do the inverse function. Execute the root, like that. Boom. However, I have another point. Another point is symmetric, is 3.0. Look at that, the symmetry. 4.1. Look at that, symmetry here. And 2.1. 3 points is enough. And the famous line y equals x, I put in dotted line. You see clear like a water the symmetry between the graph of the original function, gets the black color curve, and the is inverse against the green color curve. Cool? Clear?
Yes.
Okay, enough. Okay, guys, remember you on Monday is the due day, no? The 17th for the test. You Monday at midnight. You submit the homeworks, 3 homeworks as always, and the test number 2. Okay, cool, cool. Bye bye. Have a nice afternoon.
Have a
Bye,
good
Professor.